The notes that we started last class, you should have on the left-hand side the circumference. You should have the formula. You should have at least one example. In the center, you should have the diagram. It was a circle with a central angle given to you that was 50 degrees, and the radius was given 4 inches. So for circumference, we know that that is 2 pi r, or diameter times pi. And for this example, we found that the exact answer, when we plug in 4 for our radius, the exact answer, which also means in terms of pi, the exact circumference is 8 pi inches. We're not going to forget our units, because in this section of our curriculum, we'll be very particular about putting our units, so please do that, get in the habit of it. And then we said, okay, well, we have the exact answer, just like we're using trigonometry, and then we have our rounded, and so I think that we got, what was it? 13. 5, okay, I didn't hear 5. Awesome. Inches. And we got that by simply typing it into our calculator. Remember, we will never, ever, ever use 3.14 for pi. We'll never use that. We'll never use that in any future math class either. You get, like I said earlier, when you get to Mr. Corrali, you're going to use the symbol pi. When you get to Ms. Hardesty in pre-cal, you will use the symbol pi. Or if you plan on going to Broswell, I hope they've got some good teachers for pre-AP, Algebra 2 and pre-cal. I don't know who's going to be there. But anyways, they're going to use the symbol pi. Okay? So just get in the habit now. You're not going to use 3.14 from here on out. Well, what if we, so talk about circumference, what if we don't want the whole circumference? We don't want the length of the from one point all the way back around. What if we just want a part of this circle? Well, we know that part of the circle is called what? An arc. Okay? So now what we're going to get into is finding the lengths of arcs. And these arcs are going to be created by central angles. And we should know the relationship between the measure of a central angle and the measure of the intercepted arc. We should be really good at that. So what is the measure of this minor arc? I'm just going to add some endpoints, be generic about it, and say AB. So what is, I'm going to put it in red ink, the measure of minor arc AB? 50 degrees, because we know that the relationship between the central angle and the intercepted arc, they have the same measure. Now we're looking into length, because if I had some circular path and I was going jogging or whatever, if you're going around that circular path, you are traveling some distance. It's not just, hey, I ran 700 degrees last night. It was fantastic. Like, no one would say that if they're going around in a circle. But this is some sort of distance, and so this is what we're going to find. So right now what we're searching for is the distance from point A to point B along the circle, the length of arc AB. We're going to throw in a new little symbol for that. I'm going to use a capital cursive L. A capital cursive L, and this is going to represent the length of an arc. And I've got to be very generic about that, like the length of an arc, because I don't know what the name of the arc's going to be. So I'm just going to use this symbol, capital cursive floopy L. And that's going to represent the length of any arc. This arc is taking up 50 degrees of the grand total. What's the grand total degrees? 360 degrees. So So this is taking up a certain amount. And if we wanted to, we could figure out what the percentage is. We're not going to do that, but we could. We could say, hey, that the measure of this arc is taking this percentage of the whole 360 degrees. And so this is a ratio. Well, the length of that arc is going to be taking up the same percentage of the whole circumference, because these are proportional. So however much of the measure it's taken up out of the 360, it's going to take up the same percentage, the same ratio from the circumference. And so what we're going to do is we're going to set this equal to, and we're going to compare part over whole, because this is part of the 360 degrees, and this is the whole of the 360 degrees. And so this arc length, capital cursive L, is going to be the same ratio, the same percentage of the whole circumference. Okay, so this up here is the measure of my arc, and if we want to be even more generic, then we can say measure of arc, and that would be very, very generic. We're just saying, okay, the measure of the arc, the grand total 360, that's going to equal always whatever that corresponding arc's length is when compared to the circumference, which is the whole. And so you'll hear me say quite often, part over whole is going to equal part over whole. Whatever this ratio is, however much that minor arc, its measures taking up 360 degrees, whatever that ratio is, it's going to be taking up the same ratio, the same percentage of the circumference as well. We just set these two equal to one another. So let's apply it with these numbers. What's the measure of my arc? 50 degrees. What's the grand total? 360 equals. We don't know the length of arc AB. That's what we're searching for. So this is my unknown, is the length of the arc. The bottom is circumference. Okay, but we can determine the circumference because it's not always going to be given to us. So what you're going to have to replace that with is 2 pi r. But when you're solving a problem, you're going to put 2 pi and then whatever your radius is. In this case, it is 4 inches. What is this called, this whole thing, this equation? How do we solve proportions? Cross multiply and then solve for the variable. One cross product is going to be 360 degrees times this variable L. So it's going to end up being 360L. That's one product. Then the other product of the diagonals is going to be 50. We've got to multiply it by 2. We've got to multiply it by 4. We are not yet going to type in pi into our calculator because we need an exact answer. We need our answer to be in terms of pi. So we need to treat this just like we would like x or y or z, some variable. We're not going to multiply to these coefficients quite yet. We're not going to multiply to these whole numbers. So 50 times 2 is 100. 100 times 4 gives us 400, and then we are going to multiply that to pi. We're just multiplying all 4 of these values. 50 times 2 times 4 times pi. But we're not going to type in pi in our calculator quite yet. This is an exact answer. There is no rounding. Not yet. Maybe this will help you. If you want, you can replace circumference with what it actually is. So maybe you've already discovered what the circumference is, and you've done a little bit of side work. Okay, well now, 50 times 8 gives you 400. And so we still need to multiply it by pi. Because pi is not an unknown. It's not a variable. We know what it is. It's the ratio of, for any circle, the circumference divided by its diameter. That's what pi is. So we know exactly what that value is, and we have estimations for it. So this is not a variable. We're not searching for that right now. What we're searching for is this capital cursive L, which is the arc length. So what do I need to do now on both sides of the equation? I'm trying to solve for L. What's currently happening to our unknown, what's currently happening to our variable L. We multiplied by 360, so we need to do the inverse operation, which is division, with that same exact value to get our variable by itself. So we need to do the inverse operation of multiplication, which is division. Whatever you do to one side, you got to do to the other. So I've got, and then we need to divide by the same value, so 360, so that these cancel out. And on the left-hand side of my equation, I am simply left alone with my unknown, my variable we're searching for. Now, on the right-hand side, on the right-hand side, I've got this value, 400 times pi divided by 360. How many times have I touched my calculator while I've been doing this problem? None at all, okay? Maybe you needed help 50 times 2 times 4 and you got 400. Maybe that you need help for that. But other than that, you should have not touched your calculator at all. Okay? The arc length is this value. It is 400 pi divided by 360 degrees. But like always, especially back in grade school when you're talking about fractions, we've got to reduce these fractions. So I'm going to divide top and bottom by 10. If I divide top and bottom by 10, I get 40 pi over 360. Well, I can still reduce these. I'm going to divide them by 2. So I can reduce this even further, and this is 20 pi over 18. I can reduce even further because they're both divisible by 2, and I can get 10 pi over 9. So this fraction, in simplest form, is 10 pi divided by 9. This is your exact answer. And this is what I need when you are giving me your exact answer. Make sure you put your units. What's our units for this arc length? Inches. This is the exact answer. Now, I'm sure you all remember how to reduce fractions, and you heard what I said. I divided by 10 and top and bottom, and I divided by 2 top and bottom, and I divided by 2 top and bottom, and finally couldn't reduce anymore. Is there an easier way we have learned in this class to reduce fractions? So we're going to do it by hand every single time? If not, then someone needs to tell me how we have talked about before how to reduce fractions quickly with not doing any work, really. Because I'm cool if we just do it by hand all the time. That's fine with me. What's up, Lydia?
You can divide 400 by 360 in the calculator, and then if you hit math, then enter and enter, it'll turn it into a fraction of this.
Thank you very much. So we can reduce the coefficients. We can reduce these coefficients. Notice how pi just kept going in there the entire time. So when you simplify this fraction, if you want to do it the easy way and have your calculator do all the dirty work, then you need to only type in the coefficients.